Today, let us look at area of a triangle in coordinate geometry. If we were given three non-collinear points and we knew the coordinates of these 3 points, then how would we find the area of the triangle formed by these? So triangle ABC, we know from geometry that area of a triangle is half times its base times height. Let us say that AC was the base and we dropped perpendicular BD onto it. Then although we could find the segment AC using distance formula, there is no way to find segment BD because the coordinates of point D are unknown. So we have to find some other way to find the area of this triangle ABC. Let us draw perpendiculars from the points ABC onto the x-axis. Now what geometrical figures are visible in this diagram? We can see a few trapeziums. Look at trapezium ABED. There's another trapezium EBCF. If we were to add the areas of these two trapeziums and subtract the area of the trapezium ACFD, we would easily find the area of triangle ABC. Now the area of trapezium is equal to half times the sum of the parallel sides times the height between those parallel sides. Let us look at the area of trapezium ABED. Now AD and BE are the parallel sides here. The length of these segments would be equal to the y coordinates of points A and B. So the sum of my parallel sides would be y1 plus y2. And the height, which is the distance between these two parallel lines, would be the segment DE. The length of this segment would be equal to the difference in the x coordinates. So height is x2 minus x1. Now let us look at area of trapezium BCFE. The sum of parallel sides would be BE plus CF. So I get half times y2 plus y3 times x3 minus x2, which is the segment EF. Similarly, let us look at the area of trapezium ACFD. So I get half times sum of parallel sides times height. My parallel sides here are AD and CF. Adding their y coordinates, I get y1 plus y3. Recall that the y coordinates represent the length of these segments. The height would be the segment DF. So let us subtract the x coordinates of points D and F. So I get x3 minus x1. The area of these 3 trapeziums would give me the area of triangle ABC. Let us take half common from all the 3 terms and open the brackets. A few terms would cancel each other out. Let us group terms with the same x coordinates together. So we get area of triangle ABC as half times x1 times y3 minus y2 plus x2 times y1 minus y3 plus x3 times y2 minus y1. The formula could look complicated, but there is an easier way to remember it. We are going to move in the anti-clockwise direction while looking at the triangle. So let us say we start with point A. So we get x1 times the difference of the y coordinates of the other 2 points in the anti-clockwise direction. So we get y3 minus y2. Let us move to the next point, point B. So x2 times, let us move in the anti-clockwise direction, we get y1 minus y3. Now let us look at point C. So x3 times, let us move in the anti-clockwise direction again. So we get y2 minus y1. Let us look at a few examples. Find the area of the quadrilateral whose vertices taken in order are minus 4, minus 2, minus 3, minus 5, 3, minus 2 and 2, 3. Let us draw a rough sketch, or in this case, an accurate sketch. So we get quadrilateral ABCD. Let us write down the coordinates. Now we can easily divide this quadrilateral into 2 triangles. Join any one of the diagonals. Let us join diagonal AC. So we get area of triangle ABC plus area of triangle ACD as the area of this quadrilateral. Alright, now let us see how to apply the formula for area of triangle. Let us look at area of triangle ABC. Okay, we are going to start with point A. So let us write the x coordinate -4 times, move in the anti-clockwise direction, we get -5 minus -2. Now let us move to point B. So we get the x coordinate -3 times, move in the anti-clockwise direction and look at the y coordinate. So you get -2 minus -2. Let us move to point C. So the x coordinate is 3 times. Look at the y coordinates in the anti-clockwise direction. So you get -2 minus -5. Let us solve. We get 21/2 as the area of triangle ABC. Now similarly, let us look at area of triangle ACD. Alright, you can start with any random point here. So let us start with point C this time. So you get the x coordinate 3 times the y coordinates of the other 2 points in the anti-clockwise direction. So 3 minus -2. Let us move to point D. So the x coordinate is 2 times. Let us look at the y coordinates of the other 2 points in the anti-clockwise direction. So -2 minus -2. Now the x coordinate of point A, which is -4, times the y coordinate of the other 2 points in the anti-clockwise direction. So -2 minus 3. Now let us solve. And we get 35/2 as the area of triangle ACD. Let us add these to find the area of the quadrilateral. So we get 28 square units as the area of this quadrilateral ABCD. Let us look at another problem. Find the area of the triangle formed by joining the midpoints of the sides of the triangle whose vertices are 0, -1, 2, 1 and 0, 3. Find the ratio of this area to the area of the given triangle. Alright, let us draw the triangle first. Now here we are drawing accurate images, but you may draw a rough sketch. Alright, now this time let us label the coordinates of these points as x1, y1, x2, y2 and x3, y3. If you are more comfortable writing the formula first and substituting the values, you may do that. Let us do the second problem this way. So once we have identified x1, y1, x2, y2 and x3, y3, we can easily substitute the values in this formula. So upon solving, we get area of triangle ABC as -4. But area of a triangle cannot be negative. So we are going to look at the numeric value here. Area of triangle ABC would be 4 square units. Now we have to look at the triangle formed by joining the midpoints of the sides of this triangle. Now if we are looking at the midpoints, let us apply the section formula and we would have m1:m2 equals 1:1. So my midpoint would be x1 plus x2/2 and y1 plus y2/2. So let us look at the midpoint of segment AB first. Let us apply the same formula for the segment BC and for the segment CA. So we get the coordinates of points D, E and F as 1/2, 1, 2 and -1/2, 3/2. Now once again, looking at the triangle DEF, let us label these coordinates as x1, y1, x2, y2 and x3, y3 and substitute these values in the formula for area of a triangle. We get the area of triangle DEF as -1. Since area cannot be negative, let us look at the numeric value obtained from this formula. So we get the area of triangle DEF as 1 square unit. Now we had to find the ratio of this area to the area of the given triangle. So area of triangle DEF is to area of triangle ABC would be equal to 1:4. Let us look at another problem. Find a relation between x and y if the points x, y, 1, 2 and 7, 0 are collinear. Alright, let us identify our points as A, B and C. Now we have to see if they are collinear or not. If they were collinear, which means that the three would lie on the same line segment, then the 3 points would not form a triangle, which also means that area of triangle ABC would be equal to 0. Let us draw a rough sketch of a triangle. Now once again, let us try to move in the anti-clockwise direction and find the area of this triangle. So we have half times x coordinate of point A, which is x times the difference of y coordinates in the anti-clockwise direction. So we get 2 minus 0 in the bracket. The second term, we start with the x coordinate of point B. You could also start with the x coordinate of point C. So we get 1 times difference of the y coordinates of the other 2 points in the anti-clockwise direction. So you get 0 minus y in the bracket. Moving on to the x coordinate of point C, you get 7 times y minus 2. Now this area of triangle ABC has to be equal to 0. Let us solve this equation. We have two variables x and y. And we get an equation saying x plus 3y equals 7. So any values of x, y satisfying this equation x plus 3y equals 7 would give us a point which would lie on the line joining points B and C.